can of juice or soda, you probably don't even give a second thought to the container. All right? After all, many of us drink from aluminum cans every day. But the aluminum beverage can has gone high-tech. The United States alone produces 10 billion beverage cans per year. Okay? So there's quite an incentive to keep improving the cans.
I read in a magazine that canned fruit has like BPA in it, and it gives you cancer.
Canned fruit? Oh, that's great. Okay.
Cans
There's
are
nothing wrong.
Yeah, you have to yes. Okay. Designers. Now this is where your design, those of you who are design, like to think of things. Designers enlist the best modeling techniques as they continue to make cans lighter to conserve aluminum. All right? At the same time, cans must support 250 pounds and withstand more than 90 pounds per square inch of internal pressure. Okay, you have all that carbonation inside. All right? The designers of the models consider how the volume of a can relates to a given surface area, how cans are formed, how the shape distributes stress. And they also consider aesthetics and usability. What is aesthetics?
How it looks.
How it looks, okay? They work to minimize the size of the lid, which by itself makes up nearly 25% of the can's weight. These models exemplify many kinds of functions. Think about that word, many kinds of functions. Quadratic functions represent surface area. Cubic functions represent volume. Why is volume represented in a cubic function?
there's
Three dimensions, that's right. Okay, and other parts of the model may contain terms such as 3x to the 4th or 7x to the 5th. And yet these are some of the simplest models involved in the manufacture of aluminum cans. So the next time you reach for a cold soda, take a moment to consider the not so lowly aluminum can. So I just thought that you would appreciate it's all around you. A very common topic. Okay, we're going to read the next story. Again, I think that you guys, how many of you have your driver's license? Okay, so some of you have your driver's license. How many of you have your permits? Yeah, we have a lot of people with permits. The next wave. Okay, so let's look at this. And again, I'm just reading out of the text. When you model the volume of an aluminum can or anything else, you find yourself working with expressions involving the exponent 3. Likewise, in engineering, business, economics, science, or medicine, you encounter models involving the 3rd, 4th, or higher power of a variable. Okay, so look at this picture here. The exponent, or let's see. The function a to the x is equal to a negative 0.0915 x cubed plus 1.771x models, and I thought this was pretty interesting, models the approximate alcohol consumption in hundredths of a percent in an average person's bloodstream X hours after one drink. Talking about one drink. Okay, so by looking at that, can we see how long does it take for the maximum impact of that drink? So that one glass, and it doesn't say what kind of alcohol it is. Okay, do you have a visual sense of how quickly the alcohol enters the bloodstream and is metabolized? So can you see that you're having it, this is 5, I'm guessing this is an hour, how long is this? It doesn't say if it's in minutes or hours.
It says hours.
Doesn't say, I don't see.
Yeah, X hours after one drink.
Okay, X hours, okay. So if this is, you can see that after between 2 and 3 is your maximum level of concentration. So would it make sense for us to look at the negative values? Because negative hours. Okay, so what happens sometimes is you're going to have graphs. It happens that this equation continues, but we're only interested in this section. And that's what happens when something is modeled. You know, data is collected, and somebody comes up with this calculation, and now you can approximate. Do you think that the state police have information about this?
Yeah.
I think they probably have charts. Hey, after so many, that's why they give you breathalyzers, because they know this data. Somebody designed the breathalyzer, okay, to figure out how much alcohol remains even after, let's say you've gone to a party, 1, 2, 3, 4 hours, and you know, I don't know the exact numbers of, you guys know, probably more than I do. What is the alcohol, when are you considered,
You
what?
can't, if you're our age, it has to be 0.01.
I guess
0.02 because you can get it from like cough syrup, but for adults it's 0.08.
Mouthwash.
Okay, so it's in this range, and look at that. Even after a couple of hours, you can see that. So does that have meaning to you, that graph?
Yeah.
Okay, well it should. I mean, you should be able to say, oh, I can interpret that, I understand that. You should be able to say, huh, gee, I didn't realize it would stay in my bloodstream that long. Because even after 4 hours, gone to a party, you start drinking at 8 o'clock, it's midnight, you're driving home, you get pulled over, do you still have alcohol in your bloodstream?
Yes.
Yeah, so important information. Okay, there you go. So, I'm going to give you a bunch of vocab words. Today is a vocab lesson, and that's just about it.
Should we make a big cat?
It's definitely, we are on a different tact right now.
What's the usual goal?
It is, what are we doing? We're going to be talking about, what's the chapter called?
Hey, Sarah.
Polynomials and polynomial functions.
I don't think that would show up in alcohol. Yeah, it's good. Are they totally?
And I swear,
Yeah.
I'm doing practice.
Or being mentally insane.
That's probably more likely.
Okay, we're going to do this pretty quickly because that time just keeps on moving. All right. Bradley just took it. Okay, we are going to be talking about definitions of polynomial functions. Okay, and have we been, you guys all know what a monomial is, right?
Yeah.
One term. We know what binomials are. Okay, we know that they're connected with what? An addition or subtraction. And we know what a trinomial is, etc. So that's all these are. These are an example of 4 terms. And when we have 4 terms, actually this is the 3rd power. This is the degree. We talk about this being a cubic. And we're going to graph cubics in a few minutes. Actually, we've done cubics, I believe. Okay. We know that this is to the 5th power, and we don't have any special name to that. We just say it is to the 5th power. And this one is a what? Monomial to the, what is the degree? 2nd degree. And this one is a what?
Zero.
What would the exponent be here?
Zero.
1.
1?
It's not to the
Yes.
0.
It would
But
be
it's X,
22.6. Okay. It
It's
would
X.
be x to the 0. If I wrote this as,
It would just be a vertical line.
I had, this one would be x to the 0. X to the 0 is a 1. So I know that this one is 12 to the 1. In the quadratic equation, I would say I have an x to the 0. But if I just write 5, isn't the exponent 1? Right? The exponent here was also 1. It was just that in a quadratic, they are decreasing. Okay, let me see. What else do I want you to know? We know the language of coefficients. We have numerical coefficients. We have a leading term, and I'm going to show you this in a second. Actually, we'll write this down for you. I just wanted to show you right here. So in this case, okay, yeah, well, this is what we've been doing. So I want you to see that the last term is x to the 0, which is 1, right? And then it was my number times that 1, right over here. So this is where, that's why we have a 0 there. It's a 2, 1, and a 0 for the quadratic. Okay, so don't worry about this because it looks pretty intimidating.